All right, guys, this video is just going to cover the third page of the notes, or most of the third page. So this is kind of the transition from 2.1 to 2.2. We're going to look at transforming data. This is going to be pretty important as we go through this course. So we're going to start off with just a bunch of examples in this video. This video will be pretty short, and then we'll move from there. So first thing I said, we want to make a dot plot of the following set of data. So we have 0, 0, 0, 1, 2, 3. So I'm just going to make a quick little dot plot. We have a dot at 0, another dot at 0, what's that? Another dot at 0, and then we have a dot at 1, dot at 2, dot at 3. Okay, and if you took a calculator or just do it by hand, because it's a pretty small set, to calculate the mean, median, standard deviation, IQR, you would have gotten the following numbers. So I got the mean was equal to 1, median equal to 0.5, standard deviation equal to 1.26, and I had an IQR equal to 2. Okay. So this is the little mean, median, standard deviation, IQR for this data set. Now it says here we want to add 5 to each one of these numbers and then do the same thing. So let's take a look again. So now we have a new set of data that is the set 5, 5, 5, 6, 7, and 8. Right, just added 5 to each one of those numbers up above. And then again, I can make a little dot plot. 5, 5, 5, 6, 7, and 8. Okay. Now, before we answer these questions about mean, median, standard deviation, IQR, right? This is why this is the best way to is just make a couple of dot plots and manipulate them and take a look. What do you notice about this distribution and this distribution? Right? They have the exact same shape. Okay. So anything that involves shape or spread isn't changing when you look at this, right? We haven't changed anything here. The only thing that we've done is taken our original graph and shifted it up, right? So if you think back to like your algebra 1, algebra 2 days, right? You're just like shifting your graph up, like having a new y-intercept, right? We're just moving everything along, but we haven't actually changed anything about the graph. We just moved it up. So you could probably answer the questions mean, median, standard deviation, IQR without even calculating it. But if you were to calculate them, you get the mean is equal to 6, median is equal to 5.5, standard deviation is equal to 1.26, IQR is equal to 2. Okay, so now take a look at a couple of things, right? First of all, look at the top set of numbers. So the mean and the median on both sets. What do you notice about those two numbers, right? Well, they've just been shifted up 5, which is what we did to our data set. We just moved the whole thing along. Now, same thing if I look at the bottom set of data, the standard deviation, IQR, same thing here, standard deviation, IQR. What do you notice about those? Those remain the exact same, right? Because we haven't changed the shape of the distribution at all by adding 5. Okay, so here in the top set of numbers, we added 5. And then in the bottom set of numbers, we didn't do anything. We just kept it at 0 plus 0, right? So again, we didn't shift the shape of the spread. We only shifted the measures of center, which is what we're going to call these things, mean and median, or measures of center. Okay. So we can kind of summarize this a little bit. Is what effect? What is the effect of adding or subtracting a constant from each observation? So to the shape remains the same. And that's how you kind of notice that when you move the graph up. The center is shifted based on the number. Okay, so that's either going to be a positive or a negative. And the spread did not change. This is going to be looking at your standard deviation and your IQR. Those are measures of spread. And then put up here, this is going to be, for measures of center, you're looking at median and mean. And just as a reminder, as you're kind of going through this, think about the SOCs, right? So when we have a right skewed distribution, which is what those were, which one of these measures of center is going to be better, okay? So when you have right skewed distribution, your mean ends up being skewed in the direction of the tail. So your mean becomes bigger than the median. And so that's why the median becomes a better estimator for the center of the distribution. And that's a quick little reminder about those things. Okay, so now scroll down. Okay, last few things here. So we're gonna do the same sort of deal, but this time we're gonna multiply by a number. So we're gonna double all the values. So we're gonna have the set of numbers 0, 0, 0, 2, 2, 4, and 6. Okay, take all the ones from the original set at the top and just multiply everything by 2. And if I were to make a little dot plot for this, you have values of 0, 0, 0, 2, 4, and 6. Okay, so if you looked at this distribution compared to the one at the top, right, you would notice that this one's definitely more spread out, right? We've expanded the whole entire graph, it's gotten bigger, it's gotten wider. Okay, so what do you think when we calculate these values? So if you were to go in and actually calculate some of these values, what you end up getting is the mean is 2, the median is 1, the standard deviation is 2.52, and your IQR is 4. Okay. Now again, same thing. Compare these values to the values at the top of the page, right? So what happened between the first set of numbers that I gave you, the 0, 0, 0, 1, 2, 3, and these values down here? Okay. And what you notice is that all of the numbers have now been multiplied by, in this case, a factor of 2 because we doubled it, right? This was a factor of 3, you triple it, factor of 4, you multiply by 4. So that's kind of why we're doing this. And you might be thinking, like, what's the point of doing this transformation, right? You have loads of reasons, right? One of them being sometimes data isn't linear, right? And so you can apply transformations, linear transformations from back in Algebra 1 in order to make something that looks more linear. And so you can look at how that impacts your data. You can also look at, if you have really big scales, you can take logarithms and how does that impact your transformations and stuff like that. So that's kind of the point of all this. But anyway, so what is the effect of multiplying or dividing each value? You end up with the shape became more skewed since the number was greater than 1. If the number was less than 1, graph will get skinnier. Right? If you think about it, if I multiply everything by a half, okay, instead of a 2, 4, and a 6, you're going to get you're going to get a 0.5, a 1, and a 1.5. So everything's going to kind of shrunk together. Get skinnier. The center was changed by a factor of n, right? So whatever that number is, so we times by 2 in this case. Spread did the same thing, changed by a factor of n, in this case times 2. Okay. So that's all for this video. We're just looking at different transformations. And again, if you have trouble trying to remember these, don't try and memorize them. Instead, just look at a basic data set, right? So take something that's really small like this and just calculate the mean, median, standard deviation, IQR, and then move it around, and you'll see what happens. So you don't really have to memorize these as much as just understand what's going on. And then it's just an application at that point. Okay? So as always, If you have any questions, please let me know. Shoot me an email, and I'll see you in the next video. Bye, guys.